In April 1986, Chernobyl disaster shocked the world, but it was not just an explosion. It released dangerous radioactive particles in air that spread over long distance and harmed many people. What if this horrible disaster becomes an inspiration to solve complex optimization problems? Hello everyone. In this video, we will learn about a new optimization algorithm that is inspired by history. Till now, we cover 100 plus algorithms inspired by nature, animal-based algorithms, insect-based algorithms, word-based algorithms, human-based algorithms, music-based algorithms, physics-based algorithms, chemistry-based algorithms, evolutionary algorithms. So till now we cover different types of algorithms. You can see here number of algorithms. Today we will cover unique optimization algorithm that is inspired by the greatest nuclear disaster in history. And this disaster not only affect human health but also environment, wildlife, infrastructures, economy and public perception of nuclear energy. So we have Chernobyl disaster optimizer. So this is really unique idea how author take inspiration from this nuclear disaster and created an algorithm that we can use to solve optimization problems, real life problems. So we will cover everything from this nuclear disaster to its direct effects on human health and how this Chernobyl disaster optimizer is designed, like how author take the inspiration from this disaster and how this optimizer simulates the spread of nuclear radiations to solve real life problems. Now let's start it how this real life horrible incident turns into a problem solving tool. This optimizer is inspired by the deadly 1986 Chernobyl nuclear disaster. It mimics the spread of nuclear radiation after the reactor core explosion. This optimizer transforms an horrible incident into an amazing computational tool to solve complex problems. This optimizer basically works by simulating how radioactive particles alpha, beta, and gamma spread after explosion. One by one, we will cover everything in detail. First, we will start with Chernobyl nuclear disaster, how it happened, and its harmful impacts on human health, environment, economy, and all. First, we will start with Chernobyl nuclear disaster, how it happened, so that we can easily understand how it is simulated in this algorithm. Nuclear reactor is like a big machine. Inside nuclear reactor, energy is produced through a process called nuclear fission, where nucleus of heavy atoms such as uranium-235 splits into smaller parts and release massive amount of energy. Uranium-235 rods are placed inside the reactor core. So during late night safety test in reactor 4, uranium chain reaction become uncontrollable due to operator errors and reactor design flaws. In reactor, control rods are used to absorb neutrons, and in reactor they are used to control the chain reaction. When they are inserted, they absorb neutron. When they are pulled out, they speed up the reaction. During test, most of the control rods were pulled out and this make the reactor hard to control. Plus, control rods have design flaw, graphite tips that cause power spike when inserted again. Operators were not fully aware of reactor design limitations. Decisions were made under pressure to complete the test quickly. They ignored warnings and safety protocols. During test, a sudden power surge occurred when emergency shutdown system was activated. Instead of stopping the reaction, these control rods caused a massive spike in the power. This resulted in an explosion that destroyed the reactor core and released radioactive materials into the atmosphere. Chernobyl plant did not have a strong building to stop the radioactive materials from leaking in case of an accident, and this explosion released large amount of radiation into the atmosphere. Radioactive gases and dust blown out. Wind carried these radioactive particles across Ukraine, Russia, and even as far as Europe. Rain brought down some particles. This disaster was a result of design errors and human errors during safety tests, and this explosion destroyed the reactor building and released large amount of harmful radiation into the air and resulted in immediate death. Two plant workers died that night. Thousands of radiation related cancer cases and other diseases. Workers and first responders suffer from acute radiation sickness, causing burns, even death. Nearby residents were exposed to high radiation levels, and this also increased cancer cases, especially thyroid cancer. And many animals died, while some developed mutation. And over time, some species adapted, but the area remained unsafe for humans. Here you can see three types of radiation released. Alpha radiation, that is less penetrating but dangerous if inhaled or ingested. Alpha radiations are relatively slow because they are large and heavy, composed of two protons and two neurons, speed around 16,000 km per second, that is 10% of the speed of light, and they cannot travel far in air, just a few centimeters, and stopped by paper, skin. Their slower speed makes them less penetrating but more damaging if they enter body. Next we have beta radiations, tiny particles that can burn skin and harm internal organs if inhaled or ingested, speed up to 2,17,000 km per second, that is close to 90% of the speed of light. And here each particles are much lighter as comparison with alpha particles. Third, we have gamma radiation, that is high energy rays that can penetrate the body, causing severe damage to cells. They are extremely dangerous because they can damage cells and DNA even at a small distance. Gamma rays are not particles but electromagnetic waves like X rays. They travel at the speed of light and they are highly penetrating, required dense material like lead or thick concrete to block them. This optimizer inspiration from nuclear explosion dynamics and the harmful radiation effects makes it unique. As we discussed earlier, when the nuclear explosion happened, it released three main types of radioactive particles, alpha, beta, and gamma. So when the particles released after explosion, these particles travel from high pressure areas to low pressure areas where humans are, and as they spread, they interact with human and cause harm. Now question is how it works in this algorithm. Here, explosion represents the starting point of search, with the particles spreading out into the solution space to explore possible solution. So here we have particles as the search agents, and we have three different types of particles, alpha, beta, and gamma. And here each particles behave differently. Gamma particles explore widely, cover large areas, so that is global search. Beta particles search in medium range. They are balancing the exploration and exploitation phases. Alpha particles, they focus on nearby areas to fine tune the solution, that is the local search. So what is this algorithm goal? So just like the particles in nuclear explosion try to reach a stable state, the algorithm works to find the best solution for a problem by exploring and refining option over multiple iterations. And process become more focused as the particles lose energy, helping the algorithm to focus on the optimal solution. Now let's see how this optimizer is designed. So we have three types of radiation in environment, alpha, beta, and gamma. And all particles have different energy levels and they reach areas where humans are. So here we have human as the victim, as we have the virtual environment, virtual particles, virtual humans. So we will consider here humans are walking outdoors and they're trying to escape danger, and their walking speed decrease as the radiation affect them, starting from maximum speed of 3 miles per hour, and this linearly decreases to 0. Here you can see the speed decrease equation. We will simulate the human walking speed that is decreasing linearly over time using this equation. So particles moving outwards represent search agents exploring the solution space, and as the human speed is decreasing, it reflects the search moving toward an optimal solution. So here we have humans that represent the target points for the harmful effects of radiation, and as the particles spread out from explosion, they interact with human and cause harm. Now question is how these particles attacking humans and how their movements and interactions are modeled mathematically. Now we will understand Chernobyl disaster optimizer step by step to understand how these particles are attacking human and how their movement and interactions are modeled mathematically. Step 1, we will initialize the particles. So first we will create a group of particles alpha, beta and gamma with random position in search space. Here each particle represents a potential solution to the optimization problem. Step 2, we will repeat the loop until this condition satisfy current iteration less than or equal to maximum iteration. So we run this algorithm in a loop until stopping condition is met, that is reaching maximum number of iterations. For example, if we have 100 iteration, then we will repeat the loop 100 times and after that it will display the best solution. Step 3, we will calculate the fitness score. Now we will evaluate the fitness for each particle, and fitness score is used to measure how good the current position of the particle is, that is how close it is to the optimal solution. If particle fitness is better than current gamma score, then we will update the gamma particle position. Similarly, we will compare and update the position for alpha and beta particles based on their fitness value. Here, alpha, beta, and gamma score, they store the best solution found so far. Step 4. Now for all particles alpha, beta, gamma, we will update the position based on Cartesian plane. So now we will update all particle position based on gradient descent factors and random propagation. Gradient descent factors, that is how fast particle move toward the best solution. Random propagation is used for adding randomness to ensure exploration of new areas. So first we will calculate the gradient descent factor of gamma particle. So using this equation we will calculate the gradient descent factor of gamma particle while attacking human. Here you can see this is the current position of gamma particle minus propagation of gamma particle into the difference between human position and the position of gamma particle. And we will calculate the propagation of gamma particle using this equation. So this is the area of human walking, that is the area of circle that we will calculate using r square into pi. Here r is the random value between 0 and 1 divided by speed of gamma particle. So particle speed can take value randomly from 1 to 3 lakh kilometer per second as we discussed earlier. So this value can be taken randomly, and here you can see this is the human walking speed into a random value. After this we have the difference between human position and the position of gamma particle that we will calculate using this equation. Here this is the area of circle and here this is the total distance. After this, next we will calculate gradient descent factor of beta particle using this equation. 0.5 into beta particle position minus propagation of beta particle into difference between human position and position of beta particle, and here we will calculate the propagation of beta particle using this equation. Area of human walking divided by 0.5 into speed of beta particle, which can take value randomly between 1 to 2,70,000 kilometers per second. And to normalize this value, we will take logarithm of it using this, and then we have human walking speed and random value. After this, we will calculate the difference between human position and the position of beta particle. Now, this is the difference between beta particle and the total position that we will calculate using this equation. This is the average of total position. After this, we will calculate the gradient descent factor for alpha particle using this equation. 0.25 into alpha particle position minus propagation of alpha particle into difference between human position and the position of alpha particle, and we will calculate the propagation of alpha particle using this equation. So similarly we will calculate all. After this we will update the average of total position using this equation. We will calculate here the average of total speed of these particles, that is similar to checking how close the particles are to the best solution. And here you can see the area of human walking that represent this circular area calculated pi r square. R is the random value between 0 and 1. So this circular area represents the potential, that is impact zone of the particles around the human. So first we will randomly assign position for all particles. After this we will compute fitness, identify the best fitness values and assign gamma, beta and alpha rules. After this we will update the position for gamma, beta and alpha particles using their respective gradient descent factors. After this we will calculate new average that we will calculate after updating all particle position, and then we will repeat this loop until the stopping condition is met. So that's all about this video. If you have any questions, you can comment below, and thanks for watching this video.